Hello everyone, welcome back to the class real-time system. So far we have discussed about the introductions of a real-time operating system and multitasking operating system and the scheduling strategies. Okay, so in introduction we have talked about what is the operating system and general structure, typical structure and blurred structure, and the multitasking operating system we have talked about multi-user and also a multitasking operating system, and scheduling strategies we have talked about the types of the scheduling strategies, that is cyclic and also a preemptive. So these are the things which we discussed in the previous video. So today we are going to discuss about the priority structure. Okay, so now we know that whenever it is coming to the real-time operating system, the priority is very much important. How the priority will be assigned to the each and every task. Okay, so in a real-time system the designer has to assign the priorities to the task in the system. Okay, so there are three broad levels of priority. So what are the broad levels of priority? One is the interrupt level, second one is the clock level, and third one is the base level. Actually the interrupt level is nothing but on the high level priority, and clock level is nothing but on whatever the program which is performing, it is repeatedly perform the same program. Okay, and base level is nothing but on low priority level. Okay, so the interrupt level is nothing but at this level are the service routine for the task and the devices which requires a very fast response, which is measured in milliseconds. For example, the real-time clock task and also a clock level dispatcher. And then clock level is in that at this level are the task which requires the repetitive program, such as the sampling and controlling the task which requires the accurate timing. So example, the base level and also a scheduling. So it is nothing but on the lowest level, one of the lowest level of priority which is assigned to this kind of clock level interrupts. And the base level priority, so the base level priority is nothing but the task at which the levels are low priority, either have a no deadline to meet or allowed to a wide margin of errors in their timings. So the task at this level may be allocated to a priority, or it may run at the single priority level at this base level. So these are the three priority structures. So interrupt level, clock level and base level. We'll see that what is the interrupt and what is the clock level and what is the base level. So if we can see here, it is nothing but on the priority levels in the real-time operating system. So these are the interrupts. So these are the priority. These are the task which is under the interrupt level, and these are the task which is under the clock level. So these are the task which is under the base level. Okay, so in between the interrupt to the clock level, there is a executive and also a real-time clock, and the clock to the base level there will be a the task which between the base level scheduler. Okay, so and the interrupt level forces the rescheduling of the work of CPU, and the system has no control over the timing of rescheduling. So it is instructing the process to reschedule the again, but it doesn't know when that particular program will be rescheduled. Okay, since it is beyond the control of the system, the amount of the work is done by the interrupt handling routine is kept to a minimum level. Okay, usually the interrupt handling routine does sufficient processing to preserve the necessary information and pass this information to the further handling routine which operates at the lower level. Either it may transfer to the clock level or it may transfer to the base level interrupts, and it has to provide a mechanisms for the task swapping and to save the volatile environment. See, actually the interrupt controller is nothing but a high level interrupt. So whatever the informations need to perform, so it will be preserve that particular information, and whatever the program need to perform, that control will be transferred over to the clock level and also a base level. Okay, so it will store the informations and that will be executed. That particular task will be executed by this lower level interrupts. So that is clock level interrupts, or it may be on the base level interrupt. So that is what the interrupt level priorities. And the clock level, when I come to this clock level, the real-time clock handling routine which will enter at the some interval, usually which is determined by required activation rate for the most of the frequently required task. Okay, so typically the value of this thing is measured 1 to 200 milliseconds. So the each clock interrupt is known as the tick and represents a small time interval. It's known as a system. The functions of the clock interrupt handling routine is to update the time delay time. Okay, so the time to the day clock in the system, and to transfer the control to the dispatcher. So that scheduler will select which task is to run at a particular clock time. Okay, clock tick. So I will tell you what is a tick time. I'll tell you later. So the two categories, there are two categories of the clock level. So that one is cyclic level and also a delay level. So what is a cyclic level first of all? So cyclic is nothing but the task which requires accurate synchronization with outside world. And delay is nothing but these tasks simply wish to have a fixed delay between successive repetition or to delay their activities for a given period of time. So this is nothing but a delay time. I'll show you what is the tick and also a clock and delay time. So the first of all, the cyclic time. Cyclic time is nothing but the cyclic task are ordered in the priority which reflects the accuracy of timing required for the task. Those which requires a high accuracy is being given to the high priority interrupts. So the one of the example which is given. So in this example they have taken the three tasks, the task A, task B and task C, which requires the run at the 20 milliseconds of time and 40 milliseconds of time and 80 milliseconds of time interval to the respectively. That means the task A which runs 20 milliseconds of time and the task B it requires to run at the 40 milliseconds of time, and task C it's required to run at the 80 milliseconds of time interval. Okay, so the corresponding to the tick 1, tick 2 and tick 3. So in this diagram you can see here the x-axis whatever which is represented the number 1, 2, 3, 4, 5, it is nothing but a tick. So we can tell the tick is nothing but the clock also. Okay, and the tick if the clock interrupt rate is set to the 20 milliseconds. So each and everything the clock interval which is represented here is 20 milliseconds. So each and every 20 milliseconds the tick will be generated. If the priority level is assigned A and B and C, that means that A is the highest priority and B is the second priority and C is the third priority compared to among the three tasks A, B and C. So you can see at see in this diagram at the tick A, the task A which runs at 20 milliseconds of time. So only the task A will be in the queue, so that will be selected for the execution. And when it is in task 2, you can see that in task 2 the task A is also there and then B is also there. So but the priority which is given to the A is a high priority and then priority which is given to the B is a low priority when compared to A. So the A will be executed first, then the B will be executed. That's why arrow mark which is represented after A, the B which continues. And at the time of 3, at the time of 3, the A which executes, there is no task in that. And then at the time of 4, I mean 4 in the nothing but the tick 4. Okay, so at corresponding tick 4, the A which is there and B which is there and C which is there. Okay, so in this among all the three tasks A is the highest priority, so the A will be executed first and B is executed second and C is executed 3. So whatever the rectangle line, that blocked line which represent is nothing but the CPU usage time. So that much time the CPU will be used. Okay, so okay, so in this example which is given, why it is represented in that particular tick? Because it is given that the task A which required to run at that tick 1. Okay, first clock cycle. The task B will be in the second and then task C is in the fourth tick. So that's why it is represented 1, 2 and 4. Okay, now this is one of the example of cyclic task. Okay, so in order to change the figure, in the cycle 4, A and B are delayed. If suppose A and B are delayed, then the C will be executed first, then the A will be executed second and C will be executed third. B will be executed third. Okay, so it's the same diagram, same example. Only the thing is at the time 4, if A and B is somewhat delayed, then in the queue only the C will be there. So the C will be taken as a CPU execution, taken under the CPU execution and until the execution. At the end of the execution, A and B which is available in the queue, among those two A is the highest priority, so A will be selected first and then B will be executed next. And the fifth clock cycle, as usual, the A will be keep on executing. So this is one of the example, task activations example. And the third one is, if the clock level task which requires a longer time to complete between the clock interrupts to complete its processing. Okay, now let us take the C is nothing but 25 milliseconds of time, and A takes 1 milliseconds and B takes 6 milliseconds to complete the process. A is delayed by 11 milliseconds at every fourth invocation. So hence the cyclic task that is guaranteed to complete within the clock interval is given to the high priority. So if you can see here, the task A which takes to complete the process is 1 milliseconds of time. Okay, each and every cycle 1 milliseconds of time which is taken for the execution, and then task C which takes the 25 milliseconds of time to execute the particular task. Okay, so we know that it is started at the time the tick 4, so it is starting at the time 4, it will execute 25 milliseconds of time, CPU time, but A which executes only 1 milliseconds of time, and B which takes the 6 milliseconds of time. Okay, so and A will be delayed 11 milliseconds every fourth invocation. So every fourth tick clock cycle, the A will be delayed by 11 milliseconds because the C is executing that many times. That much time the C is executing. So the A will be delayed by 11 milliseconds. Okay, so this is one of the examples of clock. And then second type of the clock delay is nothing but clock level is nothing but an delay task. So this task which wishes to delay their activity for the fixed period of time, either to allow the some external event to complete, or because they run at a certain interval, usually run at this base level. So the base level is nothing but what? It is a low level interrupt. So low level task which is come under the base level. So when the task which requires a delay, its status is changed. What is the status? Changes from running to the suspended state and remains suspended until the delay period has elapsed. Okay, so one method of implementing the delay function is to use a queue of the task descriptor. So we know the task descriptor which contains all the information about the task, what is the current status, where it is exactly, and when it is interrupted, and what is the name of that particular task ID, and everything, what is the priority of that. So everything which is intimated in this the task descriptor, and says the identified by the name which is delayed. Okay, so when we need to use the delay, so because it waiting for the some other external events to be occur, or this particular task need to be executed after the some task execution. So in that time the delay task must be used here. Okay, when the task is delays itself, it calls the executive task which calculates the time when the task is next due to run and insert the task descriptor in the appropriate place in the queue. Okay, so the task running at the clock level, that could be a dispatcher, checks the first task in the delayed queue to use if it is time for that task to run. Okay, if it is due to run, then it is removed from the delayed queue and place it into the running queue. The many operating system does not support the cyclic operation, then the user must use the delay function. Okay, so this is about the delay task, and the next is base level priority. So the third one is the base level priority. The third one is nothing but the low level priority. So this task at the base level are initiated at the demand rather than the some predefined time intervals. So the demand may be a user input from the terminal, some process events or some requirements of the data is being processed. The way in which the tasks at the base levels are scheduled can vary, time slice on a round robin basis, and the most real-time system which uses a priority strategy even for the base level, it may be on fixed level or it may be on the variable level, and then dynamic priority can be carried out using the high level scheduler or ad hoc basis from the within the specific task. Okay, so and these are the references. So in this topic we have discussed about the priority strategies. So the priority is nothing but the real-time operating system. For each and every task we need to give the priority. So based on that, the priority level is divided into three: interrupt level, clock level and base level. Interrupt level is nothing but high level interrupts. So whatever the program need to execute, that will be stored the information, and that controlling informations will be sent to the interrupt level. So the second level and also a third level. The second level is nothing but the what is it? The interrupt level, sorry, clock level and also the base level. Okay, so that will be execute. So each and everything which is stored, and then whatever the processing need to performed by the lower level interrupts. Okay, so in that clock level it is repeating, keep on repeating whatever the process which is executing, and in that there are two tasks. One is a clock task, delayed task, and also a cyclic task. Okay, and base level is nothing but a low level interrupts. So this is what we have discussed in this video. Okay, I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.